All right, I think we are about ready to begin. I want to say hello and welcome to the latest on-demand webinar in the NIMBL Info series. I'm Jake Eisbart, part of the NIMBL marketing team. We're thrilled to have you join us today for a digital twin approach to transforming manufacturing. A little bit about us before we start here at NIMBL. We are an SAP Gold partner, providing both technical and functional business solutions and support for our clients, whether they be mid-market or large enterprise. Our focus areas include S/4HANA, both on-prem and in the cloud, SAP Analytics Cloud, SAP Cloud Platform, SAP Leonardo, Solution Manager, and User Experience. We are proud to be a 2019 Innovation Award winner for bringing real-time analytics to the San Francisco 49ers, as well as a 2019 Pinnacle Award finalist as the S/4HANA Cloud Partner of the Year. Here's a list of some of the books that we've published through SAP Press. They can all be accessed through sap-press.com. And let's get to our presenter. We're thrilled to have Nathan Williams join us today. Nathan is a practice director here at NIMBL. He oversees activities related to strategy, design, and implementation of solutions based on SAP technology. He has over 10 years of SAP consulting experience, and he is a published author, having written 2 SAP Press books. At this point, I'm going to hand the presentation over to Nathan. Nathan, you can go ahead and accept the screen and take it away.
Thanks, Jake, for the introduction, and thanks and welcome to everybody who has found their way to the webinar today. As you can see by the contents of the agenda, we've got a customer story to share with you today. We only have 4 topics, but there's a lot of content packed in here, so let's get right into it. Let's first talk about the agenda and what we're going to cover today. Our focus today is to share how NIMBL aided a large enterprise manufacturing company who happened to be leaders in their industry and across their competition. We'll talk about Gates, the large manufacturing company, and how they really pushed the boundaries of innovation by leveraging different intelligent technologies, by leveraging SAP Cloud Platform, and also several Industry 4.0 principles. We'll start out by providing a high-level overview of who Gates is, what they do, what their business entails, and then we'll transition into something called the connected CRIMPER. And this was the solution and the business case that we'll talk about today, and how the connected CRIMPER really became a huge opportunity for Gates to offer this next level innovation to a very large segment of their global customer base. And after we discuss that whole connected CRIMPER solution, I'll dive a little bit deeper into which technologies we leveraged on the project. So ranging from an Android application that the NIMBL team developed, to HANA Cloud, to applications from SAP Fiori, and also Analytics Cloud. Finally, I'll wrap up by sharing how both the challenges, the opportunities, the lessons learned presented in the Gates story, along with technologies from SAP, might apply to your organization. So our objective today really is to showcase a real-world example of how creating a digital twin for machinery adds value to really everyone in the manufacturing ecosystem, whether that be customers, distributors, or both, and how technology, specifically technology aligned with Industry 4.0 and HANA Cloud services, can help that journey. So let's dive into it. Quick overview about Gates. Gates Corporation is a Denver, Colorado-based large enterprise manufacturing company. They make power transmission belts and fluid power products. And these products are used across a wide range of both industrial and automotive applications. There are about 14,000 people in Gates worldwide, and they've got both sales and manufacturing operations all around the world. And they design, they manufacture everything from industrial belts to hoses and hydraulic products for across a wide range of industries. And what's important to know here is that Gates is really invested into research and development and also technology. So their emphasis is on creating products that not only outperform specific standards within their industry, but also to really wow and exceed their customers' expectations. Gates is really known for kind of pushing the boundaries of material science and innovation. I think the story that we'll tell today and this new product offering with the connected crimper is really a testament to that. So let's talk a little bit about what a crimper is. So I'm going to refer to a crimper several times today, and really a crimper it's an industrial machine. It's an industrial machine that is used throughout the world that essentially attaches different items or pieces to hoses. So throughout the world, people in plants, people in shop floors, in fields, they're using one of these industrial machines or a crimper to attach these parts. So it just so happens that Gates makes these crimping machines, and they also make the rubber hoses that are a part or a component of what this operator is attaching together. So I'm going to overgeneralize and somewhat simplify this process, but essentially you have a technician, like you see on the screen, looking up different specifications in a manual or a book. So those specifications or the part numbers might be aligned with hoses or couplings, which PSI should they be crimped to, which die set should they be using, so on and so forth. So in a nutshell, the operator loads the die set into this machine, a ram lowers and performs a crimp or attaches those products according to specific specifications. So it's a pretty easy and straightforward process, but really the objective is to accurately perform these factory assemblies. Not only accurately, but quickly and also safely. So what are people doing today to crimp the Gates products? What's the process? Well, they use a book like you see on the screen. So kind of a more of a relatable example is, say you go to like an AutoZone and you need an air filter for your car. You might go to the counter, you might flip through the manual, or the employee might flip through the manual and find the specifications or the part number. Well, these crimpers are pretty much traditionally the same way. You've got people looking at the hoses, you've got people looking at the parts, the PSI that's required. So it's a relatively low-end device, but it is used extensively both in the US and worldwide. So that being said, and having kind of an understanding of the traditional way of these industrial machines being used in the field, what are some of the challenges? Well, for one, these machines were not connected to the internet. So all of the activity that's performed on these machines is limited and to the machine. There's not any of this data that's being captured. There's not any of these insights that are being sent back to Gates, for example. So there's really a limited understanding of what is being used or what's being performed on these machines. So one, from a usage perspective, so there's limited insight onto what products are being used, when are they being used, where are they being used. And also from the user's perspective is they're looking at a manual without updated content or real-time updates or new product offerings. So this entire process, both from an end user perspective or an operator perspective, as well as from a kind of sales and marketing perspective, was in dire need of modernization. So this is literally a decades old process. So what were the objectives? So the objectives were to enable smart technologies, to enable connectivity, to internet connect these industrial machines so that crimper activity, crimper usage was captured and then sent to a database, HANA, and then using visualizations and dashboards, understanding that data to not only improve the customer experience, but improve the business as well. So the objectives were to, again, connect those machines, automate as much as possible, and have all of this done in real time. And I'm going to double tap on each one of these objectives as we kind of go through the slide deck. So painted a picture of the traditional crimpers, right? Dumb machines, no internet connectivity, manual processes. Outline the objectives and what we were trying to accomplish. And here you have a picture of today's crimpers. And at a high level, these crimpers have an Android tablet that allow the machine operators to perform their activities using a large button and a touchscreen surface. The data about the crimper, so for example, the location, whether the crimper is online versus offline, what version of the Android application the user has installed, is sent to HANA Cloud. Also, information about the crimp or that activity itself are also sent to HANA Cloud. So for example, which products are these customers using? How many crimps are they performing in a set time frame? So the idea and the objective here is for the sales and marketing can use SAP Analytics Cloud, either on their desktop or mobile device, to understand this data in a simple, aggregated, intuitive, efficient manner in order to gain business insights into these activities. So I'll go a little bit more detail into each one of these, but you can see the vision here, from traditional crimping to essentially enabling a connected machine as a digital twin. So at a high level, what was the solution and what was the outcome? So the solution over a series of several technology areas was we developed an Android application and a Bluetooth-enabled circuit board. We attached sensors and solenoids that were embedded on this machine that analyzed different machine activities. And we enabled HANA Cloud services to aggregate, consolidate, and visualize these real-time machines. So the idea was that all of the crimp activity is performed, it's captured, and it's sent to HANA in real time for the business to quickly make decisions and improve different areas of the sales and marketing and demand channels. So it's important to know that the outcome was Gates was the first to market this product as an innovative new offering. So as a result of this project, they delivered a new product to the market. And this literally takes a process and products that have been used for decades, is now modernized, and it's literally disrupting traditional manufacturing processes. Nothing like this has been done on these processors or these machines, and it is a completely new way to do next level innovation. So let's talk a little bit about the project and how the connected crimper came to life. So our project was divided into two phases. You can see on the screen here. We started first with an engineered prototype. So NIMBL worked with an engineering partner to develop this prototype. The first phase of this really started back in October of 2018. And it was about a 10-week effort until we realized this engineered prototype. The idea for the first 10 weeks was to build something that could prove our end goal or our design at a kind of a foundational level. It wasn't a perfect product, but it had to meet specific requirements. So the wires were hanging out of the back. It wasn't, a fully ready product. It needed to prove that we could essentially crimp a hose within spec or within a certain tolerance. We also needed to showcase that we can develop an Android app, and that app can control the device over a Bluetooth controller. Also needed to prove that we could build out a custom printed circuit board. Importantly, we needed to show that, through all of these activities, that the activities that we're performing could be sent to HANA Cloud in real time. And we needed to show that we could report over that data in Analytics Cloud. So once we finished the engineered prototype, and we got executive approval, then we moved to the manufactured prototype phase. So in this phase, it was a series of software aspects. So continual app development, continual app testing, creating Fiori applications over HANA Cloud. So Gates administrators had a quick, intuitive, efficient way to maintain master data, and also finalizing some dashboards in Analytics Cloud. But really the long pole in the tent in a manufacturing prototype is the manufacturing and the engineering of the actual product. So selecting a contract manufacturer, understanding and defining the tooling process, sourcing the components, finalizing logistics of beta testing and who the beta crowd is going to be, implementing fixes and feedback based off of that beta testing, and then finally shipping out these production units. So you can see that two-phase project approach for these activities. A key component of this connected CRIMPER solution was to include, or a key requirement, was to include a tablet on the CRIMPER itself, on this industrial machine. So as part of this project, the NIMBL development team created an Android application that essentially was pre-installed and bolted to this industrial machine. So the setup, using the application to actually do the crimps, updates of the application, that was either included or automated. It's very intuitive for whoever it was setting this up or doing the crimps. We enabled the setup so it was wizard-based, so the operator could quickly, intuitively go through the setup of the application. Everything was Gates branded, colors, logos, UX design taken into account. Marketing and training content is also made available from the tablet. Safety videos also available on the tablet. So, for example, if I'm performing a crimp and that RAM is lowering, there might be a few seconds before it reaches the hose to do the attachment. That operator using that machine could be presented with a marketing video, for example, on a Gates product. Also, what's important is that this application is agnostic. So our project was geared towards one specific model of the CRIMPER, but Gates has a number of different models for different purposes and sizes. So our solution, both from the back-end SAP application perspective and the front-end Android application, was built with the notion of innovate at scale. So even thinking further into rolling the application out to multiple continents, other countries with different languages, we enabled a code base that supported that. Just a little bit more on the Android application. As you can see by the screenshot, there's large buttons on the screen. So this is, of course, ideal for the types of environments that these crimpers could be in. So shop floor, people wearing gloves maybe. So if you think about like a Midas, a manufacturer, a service center, the people working in these environments need, clean, precise information, big buttons, and a very user-friendly app in that sense. So also the technicians performing the crimps, they've got their own profile on the tablet. They're able to mark and store favorites. For example, if they're using a hose over and over or a coupling, they're able to do that. And that information also is reported back to the analytics. So in the sense that it's identified that a user is using the same product over and over, well, there might be a new product to replace that or a better product. And so we can use that information in order to drive that channel. There's also the ability for the machine to perform crimps while the tablet's offline or where there's no Wi-Fi connectivity. So this is really important because these crimpers are used underground, they're used in fields, they could be used in mines. So all of the offline crimp operations, all of the offline crimp statistics could then be synchronized to HANA Cloud once that machine becomes connected to the internet again. So in addition to being able to crimp some parts, this industrial machine, this industrial twin really goes beyond that. So we talked a little bit about having an Android application to automate these crimps or make the crimping activity easier, but it's much more than that. So the connected crimper solutions means having this application on a crimper with training content, with marketing content, with safety videos, access to updated crimp specs and products, and then when a crimp is performed, sending all of that data back to a cloud-based environment. So what data am I referring to? So where are the crimpers located geographically? What are the products being used on the machine? What hoses, couplings, die sets? Is the operator storing favorites? Which crimper hasn't been online in a while? Which ones are offline a lot of the times? Which crimpers haven't downloaded the most recent application update? So all of these, whether they're business insights, whether it's data about the machine itself, whether it's usage statistics, now enable that organization to run reports over that data to better serve their customers. So I want to transition into understanding a little bit about the technical architecture for this solution and how a machine, IoT data, HANA Cloud services all come together and orchestrate this concept of a digital twin. And before I dive into kind of explaining this diagram in broad strokes, I want to note that we didn't use this architecture as the starting point during design thinking. It really starts with defining the what in terms of business value. So in terms of what is Gates trying to achieve? What is the business objective at the core? What problems are we trying to solve? And at NIMBL, that's really a big part of who we are and how we approach projects. We want to understand the business challenge first. So we want to look at the internal components as well as external. So external meaning, what are the industry trends? What are the latest technologies in the market right now that could potentially resolve this business problem more effectively? Also, what's important is taking a look at what does the customer already own from an SAP Cloud Platform perspective or a SAP HANA Cloud perspective. So if there's an opportunity to leverage something that the customer owns, let's take that into consideration as well. So from understanding and analyzing that picture, we really then break it down to determine, what are the capabilities that are required in order to realize this solution or meet the business objectives. What are the analytics? What are the people skills? What insights? What's the architecture? What are the integration points to consider? So once that overall technology blueprint is materialized, after we do the prototyping, after refining the business case, then only then do we really start thinking about the technology aspect of the solution, and then mapping each one of those technologies to essentially a digital initiative. So, and that's what we're displaying on the slide here in this architecture diagram. And I want to make that, very clear. Digital transformation, scalable innovation, it begins with that vision. And it really begins with identifying all those problems and using effective design thinking. And ultimately, through that process, it's really pushing the envelope with regards to the possibilities for innovation. So Gates, their vision was to evolve this low-end legacy technology in order to gain business insights. So we took a look at what do they already own? What are the best technologies to do that? What are the best SAP technologies to do that? And then this is the architecture diagram that was stood up. So you could see, overall, it's a pretty light footprint from a technical perspective. The solution is somewhat straightforward from a BOM perspective, right? So I'll quickly walk through these. On the left, you've got the crimping machine. There's a live connection to HANA Cloud. It's using an OData connection. That data is sent to HANA. So that's the database that's aggregating the machine data, the IoT data, the sensor data, all in a central place in memory in real time so that users can then make decisions. We've got SAP Analytics Cloud as well, also live connection to the HANA Cloud. And this is so the users are able to interpret the data. It's the data in Analytics Cloud is presented and visualized in dashboards in meaningful ways so that users can make decisions. There's a Google Maps API we're hitting through HANA Cloud to enrich geolocation data. So in other words, we know through this API where the machines are. We've got the GPS coordinates. We have also got some custom-built Fiori applications that are running on HANA Cloud. This is to maintain the master data. And finally, all the way to the right, there's a data provisioning agent deployed on-premise with SDI, Smart Data Integration, which is connected to an on-premise database for the intern. I spoke pretty quickly about the applications and Fiori applications. So these applications were built right on HANA Cloud for Gates administrators to manage various aspects of master data. So such as media, serial numbers, and customer support contact information. There's the examples on the screen. So this really makes it easier for administrators to maintain this data, which typically changes, as opposed to logging into HANA, understanding and needing to have a deep understanding of SQL in order to make changes to the data. So with these applications, Gates could, quickly add entries, bulk add, delete, bulk delete, from a very simple and intuitive front end, which is Fiori. So I've mentioned SAP Analytics Cloud also. So all of these usage statistics, all of the data that's being captured on the machine, whether it's online, whether it is offline, then eventually becomes connected to internet, that's all sent from that industrial machine that we enable to be intelligent to HANA Cloud via an OAuth connection. So the amount of data collected from these machines it's enormous. So if that data is not aggregated, if that data is not organized in a way that can, effectively drive decisions from a sales and marketing perspective, then it's really of no use. So this is where SAP Analytics Cloud and these dashboards and storyboards and visualizations come in. And again, Analytics Cloud has a live connection to HANA Cloud, where this is where we're creating these dashboards and visualizations over that data, all in real time. So, excuse me. So we've discussed several things so far, right? So we've talked about how Gates, being a market leader, has really separated themselves even further from their competition by using innovation, by using intelligent tech to essentially maximize their business value. Gates realized that they could not use yesterday's technologies to solve today's problems. And by effectively using HANA Cloud services, it's not only solving their problems, but they're really pushing an otherwise, traditional legacy business into a new era, and therefore really disrupting this segment. And in the next few slides, I want to talk a little bit about the concept of a digital twin. And the use case and the success story here was a very unique machine that performed unique activities that's specific to one type of business, right? But I think one of the points and the objectives of the webinar is to take a step back and understand how digital twin, how intelligent technologies can apply to not just this specific use case, but broader manufacturing to solve real problems. And there's an analogy that I heard recently that I really liked, and it resonated when understanding this solution and these objectives. And it's with intelligent technology, you're no longer peering through the keyhole of a business problem. You're really opening the whole door. And I'm gonna make reference of that throughout the next couple slides, but I want to first kind of address and define what a digital twin is and how the concept of this digital twin can support, essentially any manufacturing organization. So whether that be general business or large enterprise, any of these organizations that are stepping into the digital era or embarking on significant innovation projects. So digital transformation in the manufacturing sector often includes IoT, connectivity. So whether that's IoT as a service from SAP Cloud Platform, or actually with our example with Gates today, the IoT was in the sense that there is a circuit board bolted onto this industrial machine that connects to HANA via HTTPS, and it's managed through the app. So right there is IoT. So either way, whether it's the service from SAP Cloud Platform or the IoT I just described, this type of connectivity really opens the door for manufacturing and other industries with regards to accessing data that has otherwise or historically been kept on that machine and isolated to specific sets of equipment. And once this door is unlocked and open, there's a ton of data that can be collected, a ton of business insights that can be captured. And really, to be successful, organizations really have to understand that data. They have to understand what actual business insights need to be gathered in order to use that data and achieve business objectives. So in the case of Gates, it was, let's understand, we need to understand how people are using the machines, where people are using the machines, and if possible, understand market trends better by knowing, which product is going through each crimping machine. So what exactly is a digital twin? So defined, it's a virtual representation that matches the physical attributes of a factory plant, product, or component in real time. And typically, it's matched by using sensors, cameras, other data collection techniques, other Industry 4.0 concepts in that manner. So in the case of the Gates Corporation, there is a sensor on the crimper. We're also collecting data via a sensor on the circuit board, and all of that's being sent to HANA via HTTPS. But if you think about other use cases, how can this apply to other manufacturing organizations? Really, the possibilities are almost endless. And for Gates, a digital twin was enabled for this industrial machine, this crimper, a product that's used in the field. So, if you think beyond that, maybe your organization, has the same use case. It's probably not a crimper that crimps couplings onto rubber hoses, but maybe there's a specific asset, within a facility or a set of facilities where this could apply. There's more than likely an opportunity to introduce a digital twin that replicates something, and that could be a machine, that could be a plant, that could be a factory, that could be a vehicle, it could be a city. In the last slide, we showed how creating a digital twin, brings to light, business insights by collecting data from machines dispersed globally, right? So here you can see that it's also a vehicle for demand generation, as well as a potential platform for e-commerce. And finally, we talked about architecture a little bit, but this is something that we also need to consider. So we live now in a world of multi-cloud, in a world with multi-platform, and we've got to really be prepared to make the choices about which technology combinations and which services need to be orchestrated to solve the business problem. So remember that SAP has a wide open ecosystem. SAP HANA is a wide open database. So there's a ton of flexibility with regards to the overall possibilities, the overall architecture, and what can be achieved now with intelligent technologies, specifically from HANA Cloud services. So whether it's leveraging, your existing applications, consolidating, integrating, decommissioning, looking outside to see what the technology trends are, these possibilities for innovation are essentially endless. And this is my last slide. I'll wrap up. I won't go through all of these bullets here, but benefits and outcomes of the digital twin, you can really see across 3 different pillars, from business and social. So modernizing a technology platform, continually improving the value, capturing and acting on business insights through the IT process as well, right? So moving towards a cloud-based process, adopting Industry 4.0 principles, having a single database that's updated in real time. And then also from the human empowerment, how can we improve the way that people are interacting with the machines? How can we improve the user experience? How can we streamline and make things more efficient? So with that, I will actually turn it back over to Jake for some additional polling and to open it up for questions. Thank you, everybody.
So Nathan, we'll get to the first question. Question is from Dan. Great presentation, but it describes a very unique business challenge. You may have actually addressed this and solution in the world of manufacturing. Can you please elaborate on how the concept of the digital twin applies beyond the Gates Corporation?
Yeah, great question. As I mentioned, I mean, the business case we talked about was pretty unique. But if you think about it, I mean, there's we use manufacturing, for example. I mean, there can be machines, there can be vehicles, there can be factories, there can even be cities, for example, where data is being collected and activity is being performed. So in any of those circumstances where there's business processes, I mean, we have the idea or the opportunity with IoT data, with machine learning to essentially enable that digital twin concept. So there's literally thousands of different scenarios in which we can apply these concepts. Digital twins, they can predict failures before they affect or damage products. So, for example, in a manufacturing line or in a quality management process, can we enable some type of machine learning or visual recognition process in order to pick out defects before products are boxed or they move along in the assembly line? How do we, is there an opportunity to analyze behaviors of products? A benchmark product. Is there an opportunity to diagnose products in the field? So in the CRIMPER sense, the sensors also detected, if there was unusual vibrations or if something was out of calibration. So, that data was sent back to Gates, and they were able to act on that before the operator or the customer even knows if there's something wrong. They're able to send a technician with parts to replace it. So when you think about quality, if you think about predicting failures, there's so many different ways to introduce these concepts.
Cool. Tara asks, can you please elaborate on timeline and cost?
Yeah, great question. Engineered prototype, like I mentioned, was about 10 weeks, and the actual project in order to ship production units out was, I believe, a 6 to 8 month project. But what I want to highlight here is everything that we have done. We built an internet connected device. You can start essentially free. So granted, you do need people, you do need skill sets, right? But the concept of building the devices can be done for free. So SAP for HANA, for Analytics Cloud, for Fiori, they provide trial accounts where you have access to all of these cloud service products for free. Android, Apple iOS, they all provide SDKs for free, right? So also with the knowledge perspective, SAP now more than ever is providing just awesome detailed content in order to ramp up in these different areas. So if there is an idea, or if you want to prototype, or if you want to develop a business case with little to no investment other than ramping up on the knowledge, you're able to do that with free resources from these technologies. And if it works, you can buy licenses. But this is a great opportunity for little to no investment for you to realize your prototype, define and refine your business case, fail if you need to, reinvent it, and then decide if you want to buy the licenses. So I just want to answer the question a little bit differently in that, yes, these orchestrating all of these technologies and bringing a new product to the market is an expensive process, but there's other ways to get started and there's other ways to get familiar with this concept.
Great. I think we have time for a couple more questions. I'll take Colin's question. Does the customer data come in real time?
Yeah, great question. Customer data is real time with live connection to both HANA as well as Analytics Cloud. If you recall from the architecture slide, there was a small on-premise component for a database that was on-premise essentially, and we had SDI and that on an SDI server, and that replication to HANA was every 5 minutes. But everything else from the CRIMPER activity to things moving into HANA is in real time. So near or real time.
Great. And unless we don't have any other questions, Nathan, I want to say thank you so much. You covered a lot of information in a short amount of time, and definitely appreciate you joining us. And thank you to everybody else who joined us. If you have any follow-up questions, you can feel free to reach out to us directly at bnimble.com/contact. Again, these are any questions on the Gates project, Industry 4.0, SAP Leonardo, Cloud Platform, machine learning, everything that Nathan discussed, or feel free to reach out directly to Nathan in terms of the practice director. He's happy to take any emails and answer any questions and set up any free demos that you're looking for. And his email can be found at the bottom, nathan.williams@bnimble.com. At this point, I'm going to wrap it up. Say once again, thank you to everybody who joined us. Thank you to Nathan, and we look forward to seeing you at our next presentation. Everybody, have a great week. Thanks.